using WinLogiLab to build and simulate logic circuits. I will demonstrate the following: how to select digital SIM from the WinLogiLab menu, how to place or delete components, how to place inputs and outputs, how to label inputs and outputs, how to connect components, how to simulate the logic circuit, and finally how to save that logic circuit. I am going to use WinLogiLab to demonstrate how to build an SR flip-flop. So first of all, you open up from WinLogiLab menu, open up digital SIM. Now, so the first thing we're going to do is to select a component. In this case, we're going to use a NOR gate. So we left click and drag, and left click and release. Now we can left click again because we want to place another SR flip-flop. Left click. Right. And next we want to have the input, right? So let's put an input, select input, drag and drop, left click, and drag again, left click. Next we want an output, select output, drag and drop, output, and we label that output. Let's see, we want the output to be not Q. Okay, and this one here, we want to label this one Q. Right. All right. We go back and we press the select. Now, if for some reason you wanted to delete a component, let's say we place a component by error, we can go to select, right? Click on the select, then click on the component, and then we can delete that component. Click delete, component is gone. All right. So we want to replace that component. We want the NOR gate. Click on the NOR gate, drag, and left click. Okay, and then you go back to select. Press select. All right. Okay, now I want to reposition this NOR gate slightly. I just go select and click on move and mouse over, left click, and I can move it, place it where I want it to be located. Okay, and then I always go back to select. All right, the next thing we want to do is to we want to correctly label all of the inputs and the outputs. So we can do that by going to the text, click on the text, right? See the text icon there, click on the text, left click on the text, mouse over to where you want the label. So let's say we want this to be our set input, left click there. It opens up the text box here, and we can, let's say I want to increase the size. I'm going to put the size to about 18 to make it quite large, and now we're going to call that set. Sorry, just click in the box, left click, okay, enter. See, and set is placed here. I want to label the bottom one reset. So again, the text box is already selected, so I just have to click here. And remember, I changed the 18 just now, so I'm going to use 18 again and reset. I've reset. Okay, I want to label my bottom output as Q. So the text is already selected, so I left click here and I just type again, I want 18 and I put Q. Sorry, left click in the space in the text box, click Q, enter. I have Q. And I want this dot one to be not Q. Do the same thing, keep it consistent, 18 again, and I'm going to say not Q, enter, and I have it. Now, if I don't like the position where these are positioned, I just go to click on move, mouse over, and I can shift, right? I can shift. Okay, if I want to put this over here, I can shift. All right, if I want to shift this one here, I can shift. I can shift this one here. I can shift. Okay, all right, always go back to select. Good. All right, the next thing we want to do now is to join. Okay, I'm going to move this one a little bit higher up. Right, put this down slightly. So here, just to get in the line properly. Good. All right, go back to no. Always go back to select. All right, so we want to join, so we have to select the wire. Select the wire. Select the wire. And now the cross here. Over the very edge of the junction here, left click. And drag across. See, I will miss it, but what we do, we can come down, stop, and we can then go across and release. Left click. And it's connected. All right, so you left click. You can bend, but if you bend it, you have to stop, left click again, and then release, left click. Okay, good. All right, so we have the inputs here, one output here, so I can shift this one up. Again, I can go straight to move. I can shift this one to be in a line to make sure that is in line with that. Just to make it thing, I can shift this one also. Good. Go back to where, and I can go from here. Go from the output, then right. Sorry, left click, and it's join. So I left click here, then I go here, I release, and I left click. Okay. All right. Now to complete the flip flop, we have to provide feedback from one output to the other one. So we come here, left click, we go up, we stop, click again, we can bend, stop, and then click and bring in, stop, and then click. Okay. Up here now the same here, left click, can come across, click, down, click, in, click. All right, so there we have completed our SR flip-flop. Now we're going to test it. To test it, we're going to go over and start simulation. Hit start simulation. Okay. And, okay, so we're going to, first of all, we're going to set the flip-flop. SR, so setting it, change the set to 1 and the reset to 0. So we see that the Q output is set. We have set the flip-flop. If we change the set to 0, then there should be no change, right? And if we hit the reset to 1, the not Q should become a 1. If we set the reset to 0, no change, right? All right, so do that again to set. Output Q becomes set. Change the set to 0, no change. Hit the reset, right? Not Q becomes active. Change the reset to 0, no change. And of course, there's for the NOR gate SR, the illegal state will be 2 1s, right? If you put 2 1s, you get an illegal output because the outputs must always be different. All right? Okay. So again, finally, so to set 0, no change, reset, 0, no change. Okay, so that is the end of the demonstration. This has been the demonstration of WinLogiLab to build a NOR gate SR flip-flop. Saving a WinLogiLab circuit. Okay, to save, we go to File. Sorry, we stop simulation first. So we stop the simulation and we go to File and we save as. Okay, we're going to give it a name. We can call it, in this case, SR flip-flop. And it'd be useful if you're uploading this to your tutor to put your name. So I'm going to say dash my name Headley. Right, so okay, and I'm going to save it. I have a folder called WinLogiLab Circuit. You can create your own folder and create save. Right, so it is saved. It's going to be saved as a .sim file. All you have to do is to you can attach that file to an email or upload it to your learning management system such as Moodle and attach it as if it was a part of an assignment. So simply save file, save as, give it a name, and then you can use that. You can upload your circuit for your instructor to check it out or grade it. Okay, so that's how you save a file.